Hey, welcome to my channel Industry 4.0. Today, in this video, we will go through the different phases of IoT Analytical Lifecycle in detail. So, let's start the video. Introduction. The IoT Analytics Lifecycle contains the phases of data collection, examining, and reprocess. This lifecycle is sustained by cloud computing and big data technologies. Those comprise data mining, statistical computing, and scalable databases technology. In this video, we will go through the different phases of IoT Analytical Lifecycle in detail. Description. There is a chance to spread Internet of Things, IoT, analytics towards the edge of the network. The kind of analytics that may be completed nearer to the edge will be more localized in nature. Then it would only be functional towards data developing from one or a few particular endpoints in the business ecosystem. For example, a fleet vehicle, a manufacturing plant floor, an offshore drilling station, etc. The subsequent data still would need to flow back to the data center or cloud. That would be to enable more comprehensive, enterprise-level analytics to be implemented and used in policymaking that reduces the IoT data more valued. The lifecycle comprises 5 stages. Generate the data. IoT data collection. Analyze the data. React the data. Predict the data. Nearly every company applying IoT finally wants to reach the predict stage. Generate the data. The first phase for any IoT project is to generate the data. This is thinkable telemetry data from the machines as voltage, RPM, temperature, flow rate, or fuel level for equipment manufacturers. This is possible data as room occupancy, office temperature, motion, and air quality for smart building applications. A lot of companies are much more in this stage than they can understand. Several machines now have classic controllers that depict all of the sensor data that's required. Sometimes, we need to generate data to eventually create business value. For example, we need to purchase and install motion sensors to know the utilization rates of the office space to generate the needed data. IoT Analytical Lifecycle. IoT data collection. The data must be collected in a central repository after it is generated. That may be retrieved and queried by the team. This repository is at times named a data warehouse or data lake. IoT data are collected and augmented with accurate related metadata. For example, location information and timestamps. Furthermore, the data are authenticated in terms of their format and source of origin. Similarly, they are validated in relation to their reliability, correctness, and stability. This phase reports many IoT analytics challenges. For example, the need to make sure reliability and quality. The IoT data collection offers many individualities when linked to traditional data merging of distributed data sources. For example, the requirement to deal with heterogeneous IoT streams. IoT Data Analysis. This stage deals with the organizing, storage, and final analysis of IoT data streams. The end analysis includes the employment of data mining and machine learning methods. For example, classification, clustering, and rules mining. These methods are normally used to transform IoT data into actionable knowledge. This is a modulation point on the analytics lifecycle when it originates to the value of the data. This is the point at which we may begin bringing real ROI. Data analysis is similarly about processing information in diverse ways in order to derive insights from raw data. React the data. The React stage is about automatically making real-time opinions from the data that feed back into a business process. React to data can be used to apply more effective condition-grounded conservation ways to reduce cost. The land may react by automatically generating a support ticket in another system. In office surroundings, conference apartments can be automatically unbound up if no stir is detected in a reserved room. In construction surroundings, water can be automatically shut off if inflow is detected after work hours. No matter the assiduity, replying to data is an abecedarian part of IoT's implicit value. Predict the data. Predicting the future can be the end result of successfully covering all stages of the IoT analytics lifecycle. The predict stage is about relating the prophetic pointers that lead to eventual failures. Prophetic analytics and machine literacy are veritably misknown and overhyped terms. They're frequently viewed as a cure-all to break any problem. The reality is that it's not magic and it requires a lot of time, data, and trouble. The ecosystem and tools around prophetic analytics are still youthful, which means nearly every design requires a significant quantum of mortal labor to apply. A large quantum of data must be collected, frequently over several times, in order to duly train a prophetic model. This quantum of needed data and time involved is why the predict stage is last in the analytics lifecycle. As you progress through the lifecycle, each stage adds fresh value while you make up the data and moxie that's needed for this final stage. For more details visit https://www.technologiesindustry4.com/2021/12/iot-analytical-lifecycle.html